Hello and welcome to episode 90, High Precision Engineering for Space, the intersection of microwave technology and additive manufacturing with Northern Waves. Today, to have a deep insight into this topic, as we never really had as such, space engineering or microwave technology related topic discussed on the podcast. To take a deep dive into this topic, we have with us Jose and Omar.
Hi,
Hi,
hi everyone.
good morning.
Good morning. So, before we take a deep dive into the topic, and as per our discussion, that what things we have to discuss basically, can we just have a brief introduction about yourself, and then we'll take a jump into the topic.
Yeah, sure. So I'll start myself. My name is Jose Rico. I'm CEO and founder of this company called Northern Waves. I have a PhD in electromagnetics as taking a background, and I started this company a year and a half ago.
Yeah, and I'm Omar Orjeira. I'm the CTO of this company. I also have a background in microwave and RF engineering. Yeah, looking forward to talk about what we do and what we can achieve with our technology.
Interesting. Again, a batch of engineers. I think we have,
Mhm.
becoming an entrepreneur. I think this is something that we have seen always in common in the space industry, and I believe, that's the thing I always say to the people. The MBAs and the management things are not really common in the space industry. We really need to always have an engineers who become an entrepreneur, because no one other than the engineers can understand the technology and how to sell it basically at the end of the day. So yeah, really glad to see this path again, from engineers to entrepreneurs. So before we actually start to dissect the topic on the engineering and the space engineering side, can you tell us briefly about Northern Waves? What is the company about? What do you do in general, in terms of technology, and what is the founding story behind your company?
Yes, so I can maybe deal with this one. So I started the company a year and a half ago here in Stockholm, so January 2023. Basically, it was founded after, well, at the end of my PhD. So I did a PhD in between KTH, Royal Institute of Technology here in Stockholm, and the University of Oviedo in Spain. And the foundation or the topic of the PhD was fully metallic AM for antennas and microwave devices. So you can see that this is kind of related with the company. So I saw the potential of this new manufacturing technology for the different components that we're currently using for communication systems. And since I saw this potential and I saw there was a gap that no company was actually fulfilling, so I thought like, okay, it's a nice topic to start working on. And then with everything that I developed during the PhD, I said, okay, I have enough to start my own startup company.
That's interesting, and I'm actually coming to that point. What is the I would say a value proposition or the uniqueness of this idea. So how did Northern Waves identify the niche of microwave components for the space industry, and basically why focus on this specific area when you also have several other things in the industry?
Yeah. So as you said, it's quite niche. So we are really specifically focusing in AM for microwave technology. And the problem is that, and that's also a value proposition. So we actually are tailored to microwave components. So we are designing and manufacturing specifically to that purpose. And typically people were using the same machine for doing mechanical parts as for microwave technology. So the roughness was pretty high. The tolerances are not the same because typically we're doing structural or mechanical parts. So
Interesting.
we saw that the potential of actually having our own specific parameters or our own manufacturing technology designed and tailored for AM for microwave components was the value proposition. So we reduced the roughness, which was one of the biggest issue in AM. And yeah, we basically tested a lot of components in the millimeter wave regime because we specifically manufacture and design for this technology. And that's our value proposition, that we achieve a really high accuracy and really high performance components compared to the other competitors.
Interesting. And just to kind of I would say dissect the definition in general, because we also have people from the defense industry and the security industry who consistently basically try to procure components for their space asset requirement. So can you also briefly define the term additive manufacturing?
Yes, so additive manufacturing, well, I think it's pretty common nowadays, but it's basically a manufacturing method that builds up the pieces from scratch. So it differs from traditional methods, like for instance, machining, where you have like a block of your material and you drill out, you remove material to create your final piece. Additive
Interesting.
manufacturing is in the sense that you start building your piece from nothing, so from scratch, layer by layer. Um,
Interesting.
and then you create your piece. So yeah, metallic AM differs a little bit, well, from the electric additive manufacturing, which is probably what people has more in mind,
Yes.
from the point that metallic additive manufacturing spreads a thin layer of metallic powder on the printing bed. This layer is typically around 20 to 30 microns, and then a laser selectively melts this powder where it's needed. And then when that layer is done, the printing bed goes down, the following layer of metallic powder is spread, and this process continues until the piece is completely done.
Interesting. And coming to the part, as you mentioned, it's different from traditional manufacturing methods. So how it differs from traditional manufacturing methods, especially in terms of producing microwave components?
Yeah, so one of the main advantages is the degrees of freedom that it gives you, not only when manufacturing, but already one step before when designing. Because if you think of building, for instance, inner cavities or inner features with traditional manufacturing methods, is either really complicated or sometimes impossible to do it in one monolithic block. Because yeah, you could do some inner features with machining, for instance, but then you will have to cut your piece in two and then assemble both pieces together. With additive manufacturing, you can create all of this in one single block, and then this avoids the step of assembly the both pieces with the possible or potential misalignment, leakage,
Yes.
etc. So it makes, in general lines, your microwave components more efficient. They perform better.
Interesting. And just to kind of deep dive into the additive manufacturing side. So from your perspective, as per your experience as well, currently with your company and in your previously in your engineering work too, what are the key advantages of using additive manufacturing in the design and production of microwave components for space applications?
I would say
So
that the biggest advantages is, as Omar was saying, you can create monolithic pieces. So instead of having multiple part assemblies, you're having one single piece. So you're not having any kind of misalignment or leakage between the different layers.
Yes.
Especially the new trend now in communication systems is going to higher frequencies. So we're going into 60, 100 gigahertz, both for space and also for defense. So once we
Yes.
go into these higher frequencies, a tiny gap between the two parts or the different the assembly that you have, or a tiny misalignment that you have is degrading the performance a lot on the component. So by having these monolithic pieces, we solve a lot of problems. And this was tested at the beginning when I started working a little bit with this AM technology. It was tested with a half lunar lens with the European Space Agency, and we saw that only by having this monolithic piece, we solve a problem on the performance of the antenna that a previous milling prototype was having. And then we also perform an optimal, let's say, mechanical model. So we reduce the volume of the part 86%. And if we think of in terms of sending something to space, which 1 kilo is around 30, 50K, if we save 86%, that's a lot of saving. So on one side, we have the performance that we improve from multiple part assemblies or other
Yes.
different technologies. And then we also have the saving cost, not only due to the weight and everything, but also personal time and the lead time, which is shorter in AM compared to traditional technologies.
Okay, that's quite interesting. And now I'd like to come to the most, I think, the core part, which is the big fat engineering related stuff, for which I believe the space industry is well known for, and I think everyone outside of the space industry gets kind of fascinated by this part. That is, designing and manufacturing process of how basically such high grade components are manufactured. So can you walk us through the process of designing and manufacturing a microwave component? Using additive manufacturing.
Yeah, that is one thing that, and it's a tricky part when we start working with some clients, that you need to start think out of the box, and because typically in the universities and where you learn how to design components, they are meant to be designed and manufactured with traditional techniques. So the problem is that we need the engineers actually to think of new shapes and new ways
Yes.
to create these shapes. So it's not designing for the milling and then manufacturing with AM. It's like you need to design for the manufacturing technology, and it's pretty
Yes.
nice that you can design something that is working really well in the computer. But once you want it to realize in an actual part, you need to manufacture it. So you need to always take into account which manufacturing technology you're having, its limits, its advantages. So it's a process of iteration between the clients and us. So we typically optimize the technology and optimize their designs to our technology. So it's something, it's a synergy that we create something together.
Yes, and as you mentioned about the optimization part, so I would like to come to this segment where, for which I think even your company is kind of started because of this wave of new space, where we have this slogan that, high quality and low cost, because the cost dropping in the space industry is something that has welcomed the even the non-space people into the space industry to start innovate and take initiatives and start producing the kind of components which were never seen before in the market. So this question is from that perspective. So how does the use of additive manufacturing impact the cost and efficiency of producing microwave components for space missions? Especially if you can let us know in terms of cost, that would be great. Of course, efficiency is also important, but I believe it's always the cost that matters, because that's kind of a breaking point for every startup as well in the industry. So yeah, please, can you
Yeah.
elaborate on this?
So of course the cost is very important, but
Yes.
also I believe in the space segment also the efficiency is quite important. But yeah,
Yes.
additive manufacturing actually is um, cheaper to produce. Like the microwave components are cheaper to produce with additive manufacturing if you compare to the machining or the traditional methods counterpart. And as Pepe mentioned before, not only the pieces, the components themselves, but if you think of the complete mission, if you can reduce the weight by up to 80%, and then you translate that to launching cost or any other associated cost, yeah, additive manufacturing really creates this really good economy, so to speak. Yeah, also when it comes to efficiency, because as we mentioned, since you can have your whole chain of transmission and reception in one single piece, you can avoid all these misalignments. You are not going to have actually energy spilling out of your system. So in the end, so to speak, all the energy you are putting onto the system into the system is going to be used to actually transmit or do whatever is necessary to do with it. So in those terms, it's also more efficient.
Interesting. And coming to the actual, process where we see the raw materials and all, because as you mentioned about both the cost and efficiency. So, from your experience and the currently the kind of components that you're manufacturing, so what materials are used in the additive manufacturing process of this microwave components, and why specifically they are chosen?
Yeah, so well, nowadays there are several materials that can be printed when we talk about metallic AM. But if we talk of what we do in Northern Waves, we typically use an aluminum alloy, but it's called AlC10 magnesium, exactly to be more precise. Um,
Yeah.
I will say that 99% of the time we use this alloy, and it's basically because it has a good conductivity. So the losses, we keep the losses to the minimum, and also it's easy to print. So most of the machines are ready to print this aluminum alloy. But of course, under special circumstances or requirements, we can also print titanium. It's very lightweight as well.
Yeah.
Um, Copper or stainless steel. We have the capability, and we've done projects in which we've printed microwave components using these materials. It's not something really common, but it comes because maybe the component, the antenna, or whatever needs to support some extra mechanical forces. So yeah, because the drawback of using, for instance, stainless steel is that you have a lower conductivity, so you will have a little bit more losses. So it's of course a trade-off. But yeah, aluminum alloy is the way to go.
And I will just add to that that it's already proven in space. So there are already parts done by
Yeah.
AEM
Exactly.
in space with this aluminum alloy. So that's why
Okay.
we are also targeting this one.
Okay, that's I would say fascinating to know. And I mean, this question just from a supply chain point of view. So you manage all this end-to-end solution productions and the raw materials by yourself, or do you also have suppliers in the market? Because I mean, even like companies like Airbus also, they have their own supplier base where they don't manufacture, I mean, basically the whole satellite by themselves. They have subcontractors. So do you also have that system in place where you have certain suppliers in the world who with whom you collaborate, or with whom you basically time to time ask them for the materials?
Yeah, in that sense, well, we cannot produce the powder since we're the startup
Yeah.
doing the designing and manufacturing. So yeah, the
Yes.
powder is bought from a company. We have a partnership with a company that is helping us on this specific topic. And then we also have another collaborations because we produce a component from the specifications up to the tested component. So we have the whole chain covered. And in that sense, we're collaborating a lot with universities since they have really nice facilities like an echo chamber, microwave labs, where we can actually test the components that we are
Yes.
manufacturing. So we can offer the client the whole chain, like from the specifications to the actual
Yes.
manufactured and tested component with a report of measurements.
Okay. And proceeding ahead a little bit, where we actually reach after the production part of the components. So how does Northern Waves test and validate the performance of its microwave components for space applications? Because I believe, even though we have used high grade metals or any other raw materials for the space component manufacturing, it's always very much important to get it tested and validated. So is that the testing is done by your own company, or is it someone from outside of the company that does testing and validation for your products?
Yeah, that's as I was mentioning, we have collaboration with mainly universities because they have
Okay.
really nice facilities. So
Yeah.
an anechoic chamber is like a room full of cones, absorbers in that sense. So inside that room, there is no electromagnetic waves coming in or coming out. So you place your antenna, which approve, which is already calibrated and everything, and then you test how your antenna is actually radiating. So that's one method to actually test. And here in Stockholm, they have in KTH a couple of facilities to test this thing. So sometimes when we need to test and validate the components, we
Yes.
basically rent the facilities for a couple of days. We do all the proceeding, and then we submit a report to the client. Um, and then we also have a VNA, so it's a vector network analyzer, where we can put a microwave device with multiple ports, and then we put the connectors, and we measure how the power is transmitted from one port to the other one, or if the polarization, for example, is changing, or the input and output. So all these things we do in collaboration mainly with universities, since they have the microwave labs,
Yes.
which I have to say that quite expensive to have it.
Interesting. And as you mentioned about the collaborations and the partnerships too. So how does your company initiate collaborations to advance its additive manufacturing techniques? It maybe doesn't have to be on only terms of manufacturing the existing components, but also possibly innovating and creating some new product lines as well. So from that perspective, can you just elaborate on this?
Yeah, so we typically we have a couple of projects now running, and we typically have the university giving some theoretical background or helping on the really deep theory. We have the startup company, which is us, typically developing the product or developing
Yes.
the prototype in that sense, and then we have the big company, which is putting the application. So we collaborate a lot with big companies and universities, having this kind of a scheme where the big company is putting the application, the university is giving a little bit on support on the theory, and then we try to manage the project and also create the actual product. That's one thing. And then regarding how we are stepping up on our manufacturing procedures, we have a partnership in Spain with a company there that is actually investor in the company. So it's helping us to actually expand and improve our manufacturing capabilities.
That's quite interesting to know. And from, I would say, a little bit futuristic perspective, because we always see that things in the space industry keep on changing, whether it's the ground segment or the satellite segment or even the subsystem or the component level stuff. So what future trends do you see in additive manufacturing for space components, and how is Northern Waves basically preparing for them?
So you mates have seen in the news recently, like a couple of weeks ago, that Airbus just printed some metallic components in space directly in the
Yes.
ISS, and it's funny because the technology that they're using is called DED, directed electronic deposition or something similar. So basically, they are, if you know FDM or the traditional common 3D printer, is using a filament to
Yes.
create the shape. In that sense, they are using metallic wire, and that technology,
Yes.
one of the only companies that is doing it in the world is called Meltio in Spain, and it's one of the investors of Northern Waves. So I think we're preparing for the future in that sense, since we're able to have this technology from the early beginning with one of the biggest players um, in the world. And then ideally, we're going to have something in orbit by the end of next year. So we are quite close to have flight heritage already preparing for the future LEO constellations that hopefully they're going to expand a lot. So in that sense, yeah, we're expanding our manufacturing capabilities, and then we're also spreading to other different manufacturing technologies. And if bigger players that Airbus are looking into this sector, definitely there's a way to do it. So maybe why not printing antennas in space like in a couple of years?
Oh, that's amazing to know. And I mean, like, looking at all the kind of great stuff that you're doing at the moment with your team, this question is more from, I would say, from a environmental point of view, because I believe no matter what, in the space industry we have started taking care of the things in terms of sustainability. But still, from your perspective, what are the environmental and sustainability benefits of using additive manufacturing in space component production?
Yeah, so this is interesting. You mentioned this. We believe Northern Wires that this is very important, and actually, I think we covered already some of these points, but maybe we didn't talk about them from the
Yes.
sustainability point of
Yes.
view. So I think one of the main points is the material waste. Like, we actually don't have any material waste, or is negligible, because yeah, all the powder, we only use the amount of powder that we need to build the piece. So if you compare to how the things were done
Yes.
before, where you have this block and you remove material, that material that you remove is typically going to waste. But in this case, with additive manufacturing, we actually only use, yeah, the powder that the piece needs to be built. So we don't waste material. Um, Also,
Yes.
when it comes to prototyping, or a low amount of units that need to be done, additive
Yes.
manufacturing is very suitable for that, because sometimes when you wanted to manufacture maybe one, two, five, tens, or a small hundreds of pieces, you need to do a larger amount of production just to save costs. That could lead to overproduction, and then yeah, resources that you are not using, and then maybe components that will end up on top of a shelf. So with additive manufacturing, it's
Yeah.
really easy to say, oh, I only need five pieces, 5 units of this component. So we just manufacture that. Also, the weight reduction that I think Pepe mentioned before. If you think this in terms of money is good when you are launching your satellite or your mission, but
Yes.
this also saves fuel in the end, which are then emissions
Yeah.
that you are not putting into the environment. And last, I will say, I mentioned that it's not very difficult to have a distributed production center. So
Yes.
different production centers in different locations, and you could, yeah, save some CO2 emissions in the logistic part by sending parts from one location to another if necessary. You
Yes.
could have potentially several locations spread around the globe, producing the things locally.
That's quite interesting to know. And I mean, this is the I would say we are coming at the end of the podcast, and this question is more from, again, the futuristic perspective. So I'd say, yeah. you can answer it the way you believe you're scaling your company at the moment. So looking ahead, what are Northern Waves plan for expanding its use of additive manufacturing in other areas of space technology?
So that's a really nice question. If you think of integrating
Yeah.
antennas in a satellite, that's a really complex
Yes.
mission. Uh, so one of the features that I believe, and that's something that we're starting to look with some clients that unfortunately I cannot disclose the name, but if you're thinking of putting something in a satellite, it is nice to collaborate together and have synergies in the different components. So it's not only manufacturing and designing an antenna, but maybe having the antenna. And that is one thing that is quite important now. That the companies, the bigger companies, are starting to think that the antenna is going to be the central point of the satellites and the
Yes.
communication systems. Once you start designing an antenna, you start designing the rest of components. So if we start by designing this antenna specifically for EM, and then we have synergies in other parts, like the support for the antenna, thermal dissipation that can also be printed along with the component. So if we do all the things together, think from the beginning, and in that sense we collaborate to create the desired shape and the desired system, I think
Yes.
it's going to be more much efficient. So yeah, in that sense, we are expanding a little bit towards mechanical designing, so supports on antennas, satellite structures, and also thermal dissipation on some components. And yeah, that's something that we are now looking with some clients for some space related applications. And
That's
how
interesting to know.
we're going to expand. So we believe in the next couple of years, we're going to expand our manufacturing capabilities, because nowadays we're not really dealing with the amount of clients that we're getting, which is really nice news from
Yeah.
our side. So our idea is to expand, have more machines, have more manufacturing capabilities, new
Yes.
technologies, and why not start to getting into different sectors. So, for example, automotive, yeah, defense,
Yeah.
why not? And then trying to cover the different sectors and needs that the clients are asking now for.
That's great to know. A lot of people always keep on asking me, why space. I always tell to the people that it's the birthplace of every technology. Maybe it's
Mm.
IMAX cameras or maybe an X-ray machine. Everything started with space. I mean, X-ray machine and everything. It was used to scan the stars. For astronomy, astrophysics purposes, and then came into the consumer market technology. So I think you are giving a birth to a new technology into the different domains again now. So yeah, I really hope in the future we see more and more innovative products and the solutions coming out of Northern Waves. And I really hope to have you guys again on the podcast, speaking about the kind of different sectors that you have ventured out into. So thank you very much again for your time, Jose and
Thank
Omar.
you so much for having us. It was a really,
Absolutely.
really nice moment here.
Yes,
Yeah,
it
thanks
was
to
it was
you.
great. Yes, it was a great conversation, and I hope the audience enjoys this episode. Thank you very much.
Yeah,
Thank you.
Yes.
ciao, ciao.